Hello students. Now we are going to start our next chapter rather, in unit number 4, and that is polarization, or we call it as polarization of light. तो क्वेश्चन अराइज होता है कि हमारे सिलेबस में क्या क्या है जो हमने पोलराइजेशन में करना है, तो दैट इज व्हाट वी हैव टू स्टडी। तो इसमें सबसे पहला जो टॉपिक आएगा ये है ट्रांसवर्स नेचर ऑफ लाइट वेव्स, देन अनपोलराइज्ड एंड प्लेन पोलराइज्ड लाइट, एंड देन प्रोडक्शन ऑफ पोलराइज्ड लाइट। उसके बाद हमारे पास आता है ये वायर ग्रिड पोलराइजर, then Polaroid, effect of intensity of light passing through the Polaroid, then Malus law, then double refraction, ordinary ray and extraordinary ray की बात करेंगे double refraction में हम, positive and negative crystals, then birefringence, nickel prism, quarter wave plate and half wave plate, and then polarization by reflection, that is Brewster's law, and polarization by scattering. Thereafter we'll study circular and elliptical polarization, and then production of elliptically polarized and circularly polarized light. तो ये हमारा सारा सिलेबस है जो हमने इस चैप्टर में पढ़ना है। तो इसमें जो ये शुरू के टॉपिक्स हैं, ट्रांसवर्स नेचर ऑफ लाइट वेव्स, अनपोलराइज्ड एंड प्लेन पोलराइज्ड एंड प्रोडक्शन ऑफ पोलराइज्ड लाइट, ये बेसिकली +2 से ही लिए गए हैं और आपने ये +2 में पढ़े भी हुए हैं। तो देयर इज मेयर द रिवीजन ऑफ दीज टॉपिक्स, और क्योंकि हमने इनको सिर्फ रिवाइज ही करना है और देखना है, तो अब या तो मैं सोचूं कि आपके लिए ये होमवर्क छोड़ूं, पर मैं इसके लिए 3 साइट्स ढूंढी हुई हैं, और इन साइट्स के ऊपर उन्होंने बड़ी अच्छी तरह एक्सप्लेन किया हुआ है कि ये पोलराइजेशन है क्या। तो मैं आप आगे आने वाले लेक्चर में, आगे टॉपिक में हम इसकी डिस्क्रिप्शन दे रहे हैं कि कौन कौन से आप साइट्स के ऊपर जाकर इनको स्टडी कर सकते हैं। मैं यहाँ भी डिस्क्रिप्शन उनकी दे रहा हूँ, पूरा जो उन्होंने बताया हुआ है। तो हम बेसिकली स्टार्ट करते हैं पोलराइजेशन से। तो पहले तो आपको बताएं कि पोलराइजेशन होती क्या है। तो बेसिकली पोलराइजेशन इज द प्रॉपर्टी ऑफ ट्रांसवर्स वेव्स। ये पर्टिकुलरली नोट करने वाली बात है कि हमारे पास 2 किस्म की वेव्स होती हैं, एक लॉन्गिट्यूडनल वेव्स और एक ट्रांसवर्स वेव्स। तो ये पर्टिकुलरली ट्रांसवर्स वेव्स की प्रॉपर्टी है, क्योंकि जो लाइट वेव्स हैं हम यहाँ इसी की मदद से, पोलराइजेशन की मदद से शो कर सकते हैं कि लाइट वेव्स आर ट्रांसवर्स इन नेचर। तो polarization is a property of transverse waves which refers to the situation when oscillations of particle of a medium is along a fixed plane perpendicular to the direction of motion of mechanical waves. In the context of polarization of light, there are electric field vectors and magnetic field vector which oscillate and constitute the wave, light waves. अब मैंने यही लिखा यहाँ कि टू अंडरस्टैंड द फिनोमेना ऑफ पोलराइजेशन विद ईज आई हैव फाउंड द फॉलोइंग टू क्या रेदर 3 वीडियोस हैं हमारे पास। 2 वीडियोस इसमें एक साइट कंटिन्यूटी में है, उसके हैं यूट्यूब के ऊपर, और एक थर्ड जो ये वाला निचले वाला मैं जो डार्कन किया ये अलग है। इन तीनों ने, मतलब ये पहले 2 जो हैं ये सांझे हैं, मतलब एक के बाद एक। पहला आप यदि इसको स्टडी करेंगे तो दूसरा अपने आप चल पड़ेगा, नहीं तो आप दूसरा भी इसके साथ कंटिन्यूसली स्टडी कर सकते हैं। तो इन्होंने पहले तो बड़ी अच्छी डिस्क्रिप्शन दी हुई है कि ये डिस्क्राइब किया हुआ है कि पोलराइजेशन ऑफ लाइट कैसे है और कैसे काम करती है। और इसमें भी ये जो नेक्स्ट साइट है इसने भी काफ़ी अच्छी तरह से पूरे टॉपिक को एक्सप्लेन किया है। तो मैं आपको सजेस्ट करूंगा कि यू कैन गो टू दोज साइट्स फॉर डिटेल्स, और भी आप उनके अच्छे पोलराइजेशन के ऊपर टॉपिक्स पढ़ना चाहते हैं तो वहाँ से पढ़ सकते हैं। पर यहाँ पर मैं आपको, क्योंकि उन्होंने ये दिए हुए हैं तो उसके ऊपर मैं आपको बता देता हूँ। दीज आर्टिकल्स हैव बीन टेकन विद थैंक्स फ्रॉम दोज साइट्स फॉर द इंटरेस्ट ऑफ द स्टूडेंट्स। तो आई होप कि आप इसको अच्छी तरह से पढ़ पाएंगे। और अंडरस्टैंड करेंगे तो हम इसके बाद फिर अपने अगले टॉपिक्स शुरू करेंगे। तो ये जो पहले 3 टॉपिक्स हैं यू विल बी टेकिंग फ्रॉम दीज साइट्स। इनकी डिस्क्रिप्शन मैंने अपने जो बिगनिंग वाला पोर्शन होता है वहाँ भी दी हुई है, आप वहाँ से भी ले सकते हैं। सो थैंक यू फॉर दैट।
Polarization. The experiments on interference and diffraction have shown that light is a form of wave motion. These effects do not tell us about the types of wave motion, that is, whether the light waves are longitudinal or transverse, or whether the vibrations are linear, circular, or torsional. The phenomenon of polarization has helped to establish beyond doubt that light waves are transverse waves. Polarization of transverse waves. Let a rope AB be passed through 2 parallel slits S1 and S2. The rope is attached to a fixed point at B. Hold the end A and move the rope up and down perpendicular to AB. A wave emerges along CD, and it is due to transverse vibrations parallel to the slit S1. The slit S2 allows the wave to pass through it when it is parallel to S1. It is observed that the slit S2 does not allow the wave to pass through it when it is at right angles to the slit S1. If the end A is moved in a circular manner, the rope will show circular motion up to the slit S1. Beyond S1, it will show only linear vibrations parallel to the slit S1, because the slit S1 will stop and the other components. If S1 and S2 are right angles to each other, the rope will not show any vibration beyond S1. If longitudinal waves are set up by moving the rope forward and backward along the string, the waves will pass through S1 and S2 irrespective of their positions. A similar phenomenon has been observed in light when it passes through a tourmaline crystal. Let light from a source S fall on a tourmaline crystal A, which is cut parallel to its axis. The crystal A will act as the slit S1. The light is slightly colored due to the natural color of the crystal. On rotating the crystal A, no remarkable change is noticed. Now place the crystal B parallel to A. 1. Rotate both the crystals together so that their axes are always parallel. No change is observed in the light coming out of B. 2. Keep the crystal A fixed and rotate the crystal B. The light transmitted through B becomes dimmer and dimmer when B is at right angles to A. Now out of B is further rotated, the intensity of light coming out of it gradually increases and is maximum again when the two crystals are parallel. This experiment shows conclusively that light is not propagated as longitudinal or compressional waves. If we consider the propagation of light as a longitudinal wave motion, then no extinction of light should occur when the crystal B is rotated. It is clear that after passing through the crystal A, the light waves vibrate only in one direction. Therefore, light coming out of the crystal A is said to be polarized because it has acquired the property of one-sidedness with regard to the direction of the rays. This experiment passes that light waves are transverse waves. Otherwise, light coming out of B could never be extinguished by simply rotating the crystal B. Plane of polarization. When ordinary light passes through a tourmaline crystal, the light is polarized and vibrations are confined to only one direction, perpendicular to the direction of propagation of light. This is plane polarized light and has acquired the property of one-sidedness. The plane of polarization is that plane in which no vibrations occur. The plane ABCD is a plane of polarization and the plane in which vibrations occur at right angles to the plane of polarization, and the plane in which vibrations occur is known as plane of vibration. The plane EFGH is a plane of vibration. Ordinary light from a source has a very large number of wavelengths. Moreover, the vibrations may be linear, circular, or elliptical. In general, wave motion, circular, or elliptical vibrations consists of two linear vibrations at right angles to each other and having a phase difference of π/2. Therefore, any vibration can be resolved into two component vibrations at right angles to each other. As light waves are transverse waves, the vibrations can be resolved into two planes, x dash and y dash, at right angles to each other and also perpendicular to the direction of propagation of light. The vibrations of the particles are represented parallel, arrowheads, and perpendicular to the plane of the paper, dots. The vibrations are shown only parallel to the plane of the paper. In figure, the vibrations are represented only perpendicular to the plane of the paper.
Polarization. In the year 1865, Maxwell proposed electromagnetic wave theory. According to this theory, light is an electromagnetic wave. It consists of vibrations of electric field and magnetic field in a direction perpendicular to the direction of propagation. Also, the vibrations of electric field and magnetic fields are confined to two different planes that are mutually perpendicular to each other. It was proved that electric field vibrations are responsible for the vision. Therefore, vibration of light means electric field vibrations. If we neglect the vibrations of magnetic field, the representation becomes simpler. Now, the electromagnetic wave will look like a pure transverse wave. Every vibrations will have a particular plane of oscillation. The oscillation can be in this direction, and even in this direction. We know that electromagnetic waves are produced by excited atoms. A particular atom may produce electric field vibrations in this direction. Its neighbor may produce vibrations in this direction. Similarly, different atoms of a material can produce vibrations in variety of directions. Due to this, a common source of light like incandescent bulb, candle flame, fluorescent lamp, etc. emit light that have electric field vibrations in a number of directions. This type of light beam which has vibrations in more than one plane is called unpolarized light. Similarly, A light beam which has vibrations in only one plane is called polarized light. The electric field vectors in the unpolarized light can be resolved into vertical and horizontal components. Now, this is the simpler way of representing an unpolarized light. However, this is only a front view of the wave. On the side view, the wave is represented in this way. Here, the arrow represents vibrations in the plane of the paper and the dots represent the vibrations in the direction perpendicular to the plane of the paper. Polarization of light. When an unpolarized light is allowed to pass through a Polaroid, let's call it as a polarizer, out of all the vibrations of light, only those vibrations pass through the crystal which have vibrations parallel to the crystallographic axis. Here, the crystallographic axis is represented by the dotted line. Now, the emerging light is a plane polarized light. It contains vibrations in only one plane. The phenomenon of restricting the vibrations of light to particular plane perpendicular to the propagation of light is called polarization of light. Now let us learn about two important terms used in this topic. One, plane of vibration. The plane ABCD here that contains vibrations of the plane polarized light is called plane of vibrations. Number 2, plane of polarization. The plane PQRS perpendicular to the plane of vibration is called plane of polarization. It is also the plane in which there is no vibration. If I0 is the intensity of the unpolarized light, then the intensity of the polarized light I coming out of the Polaroid is given by I is equal to I0 by 2. Now, if we pass this plane polarized light through another Polaroid, we will call this as analyzer. If the pass axis of polarizer is parallel to the pass axis of analyzer, the emergent light will have no change in intensity. That is, when theta is equal to 0 degree or 180 degree, the intensity is maximum. That is, I is equal to I0 by 2. I0 is the maximum intensity. If the analyzer is rotated by an angle theta, then the intensity of the emergent light decreases. When the pass axis of the analyzer is perpendicular to the pass axis of the polarizer, then no light will be transmitted out of the analyzer. That is, when theta is equal to 90 degree, then the emergent intensity I is equal to 0. Now, Malus law states that when a completely plane polarized light is incident on an analyzer, the intensity of emergent light varies as the square of the cosine of the angle between the polarizer and analyzer. That is, I is equal to I0 cos square theta. Polarization by reflection. The simplest method to produce plane polarized light is by reflection. This method was first discovered by Malus in the year 1808. It was found that when an unpolarized light is incident on a surface of transparent medium like water or glass, some part of the light got reflected and the rest got refracted through the material. Here, the straight arrows represent vibrations perpendicular to the plane of the surface, and the dots represent vibrations parallel to the surface. Now, If we observe the reflected light, we can see that it contains more number of dots than the arrows, which means that the reflected ray is partially polarized. Similarly, if we look at the refracted ray, we can see that it is almost unpolarized. It was found that as the angle of incidence changed, the degree of polarization of the reflected ray also changed. Then, at a particular angle of incidence, the reflected ray is completely plane polarized and the vibrations are parallel to the surface of water. This particular angle is called Brewster's angle or the polarizing angle. Brewster's law states that when a light is incident at polarizing angle theta p at the interface of a transparent medium, the refractive index of the medium with respect to the surrounding medium is equal to the tangent of polarizing angle. That is, n is equal to tan theta p, where n is the refractive index of the medium with respect to the surrounding medium. Using Brewster's law, we can calculate the polarizing angle of a medium whose refractive index is known. For example, for glass whose refractive index is 1.5, the polarizing angle is found to be 56.3 degree when the glass is surrounded by air. Similarly, when water is surrounded by air, if the refractive index of water is taken to be 1.33, it is found that the polarizing angle for water is equal to 53 degree. Polarization by scattering. Just as unpolarized light can be partially polarized by reflection, it can also be polarized by scattering. This is also known as Rayleigh scattering. Since light waves are electromagnetic in nature, they will vibrate the electrons of air molecules perpendicular to the direction in which they are traveling. The electrons then produce radiation that is polarized perpendicular to the direction of the ray. However, there is no polarization parallel to original direction of the incident light. The light perpendicular to the original ray is completely plane polarized. In all other direction, the light scattered by the air molecules will be partially polarized.